Hey guys, so the other night I was in my shop and I was winding down from the day, and I decided that I would take a little time to clean up some G code that I had already trialed. This particular G code is for a humbucker pickup cavity. It's something that I've already tested. It's been used on my guitar rebuild that I'm doing, where I'm basically rebuilding of this Flying V guitar. If you haven't seen that video, I'll post a link up here where you can click on the link and look at it. And for the rest of you, before I lead into the G code, I'll snag the segment of the video where I'm carving the actual pickup pocket so that you can see physically what this G code actually does. But anyway, I was sitting there, and as I was going through the G code and dissecting it to add my comments, and breaking up my passes, and basically setting up subroutines and doing my programming around shifting my offsets and such. I thought to myself, well, there are a lot of people in the community who would probably have an interest in and really would like to learn how to do this on their CNC machines. So I thought to myself, well, before I shoot the video, I'll post this as a question. And I went to some of the Facebook pages where I'm a member, and I posted the question concerning the video. And although I'm not completely surprised by the response, more people responded the first day than I thought would. And as of right now, which was a day following the post, somewhere around 300 people have commented, either liked or commented, where they would be interested in watching this video and learning how to do this. And one of the topics that I saw in a different video that made me think that might be a good thing to cover this is I did this for years industrially. This was part of my job and engineering and controls engineering for one of the companies where I was employed, and I saw a video where someone posted where the pattern that they repeated, because they basically carved multiple of these products at one time. They generated all of these in VCarve, and while VCarve is very good software and I love it, it's not the best way to do this. The best way to do this is to generate your toolpath, your toolpaths for one of whatever it is that you're carving, and then to go into the G code that's generated after you carve one and you trial it, and it does meet your expectations, and then turn around and use offsets and subroutines so that when you repeat it, you don't have hundreds, if not thousands, of lines of code. But anyway, for all of you who have seen the video, I'm going to post right now. I'm going to take a moment to post a short segment of the video showing my CNC carving this pocket so that you'll recall what this G code actually does. So now that you saw what the G-code does, let's dig in. And what I would like to do is I would like to begin by first showing you what we're doing within the G-code, and then I'm going to show you. After that, I'm going to show you a template that I made really quickly that will kind of break down what we're going to do. But let's start up here with line 1. And first and foremost, I'm using Notepad++, and if you look in the description of the video, I'll have a link. I'll post a link for Notepad++ if you don't already have it. I'd recommend that you grab it and use it, but you don't have to. You can use just the standard Notepad that comes with Windows. But I like Notepad++ because you can configure it to display in certain ways around what you're doing, and also I like that it has the line numbers. Okay, so anyway, let's get on with it. When you see the percent sign in the beginning, the percent sign is a flag for the controller when it reads this, that so that it flags the controller and tells it that everything that follows is a G-code routine. And G-code, by the way, I know most of you already know this, but if you don't, G-code is the type of programming language, if you will, that CNCs run. That's what they execute for cutting parts. Now, if we continue to line 2, we see a set of parentheses with this message Vectric post revision in here. When you see an open parenthesis followed by text and a closed parenthesis, this is one of the methods for telling the processor that this is a remark or comment, just to ignore it. And there are a couple of exceptions to that. One of them is right below here with the M0. The M0 command, and M is a machine code. So M0, this is a machine code to tell the controller to await the cycle start signal. And then if you look after the open parenthesis, you see MSG. When the controller sees this, it will display this message. And that's where this comes from when you see the message pop up on your Onefinity CNC that says, hey, click continue after the spindle's up to speed or whatever. That's where this comes from. And when the controller sees this, M0, it will stop whatever we're doing here. So this is handy to know because it means that you can use this M0. You can use this to put stops throughout your code if you want to execute a program, but you want it to go to a certain point and stop and let you check things and await cycle start. So you would just plug an M0 in. So we continue on down, and there's another comment that I added. That's just so that when I read the code that I know this. Also, I added this 1/4 inch mil touch off on the blank so that I can remember that this is based on the center and that it's based on touching off on the surface of the blank. We go down here to T4, and T4 tells the controller to load tool number 4's data. And I want to show you the other way now to add a comment. If we add a semicolon, that's a comment. Everything, or a comment flag, everything to the right of the semicolon is considered a comment or a remark. So I'm going to say load tool 4 data. And I'm just doing this to demonstrate. So we get down to line 7, and line 7 is an example of what we would call a safety block. And G-code programmers generally do program in a safety block early in the program, in each of their programs. And this is to make sure that the machine is in basically a machine safe state before it starts executing the G-code for your particular routine. And you'll understand this more as we go through it. We start with this G0 command. And G0 is the command for rapid traverse, but there are other G codes that require the use of G0 before that G code will be loaded into memory and also executed. And some of these are present in the safety block, like G40, for example, requires you to execute it with G0. And then we go over to the right of G0. And by the way, G-code is executed like basic programming, left to right, top to bottom. And when you now, there are some situations, and you're going to see these in a moment, where you can jump throughout the code just like you could with basic programming. So G17 is one of the 3 plane select G-codes. G17 tells the machine that we're using the X and Y plane, and that's basically making sure that the controller knows that X does literally reference X and Y literally references Y when you go through and you start executing the actual motion commands that are based on X and Y positions. And we're going to look at those in just a second. You can use G18 or G19 and change that plane. I wouldn't recommend it. G18 is X and Z, and that is so that every time that your controller sees codes such as these, instead of moving the Y, it will move the Z in place of the Y, so that if you have an arc or a linear motion, you can make it linearly go down. And I would not do this. I would be real careful with this on a CNC router because of the damage that could occur, and also how dangerous it can be. These are very nice, cool little machines, but there is a potential. You're using a mill and you're carving wood, and in both cases, not only is the media hard, but your tool is hard. If it snaps, it can hurt somebody. G19 in place of G17 would load the Z-Y plane, where Z is used for X and Y is used for Y in any of your motions. G90 tells the controller that we are in the absolute mode, and there are 2 types of movement modes. One is absolute, where it uses the absolute coordinate system, and then the other one is G91, which is an incremental mode. And using G90 means that everything is based on an absolute position relative to 0, 0, 0. G91 means that all of your motions are based on movements away from the last position that you actually were in. So like, say for example, you said G01, which is a linear motion, and you said X10, Y10. Well, now the controller will go 10 units in the X and 10 units in the Y, and it'll stop there. And then whatever your next movement is, you have to tell it how many units to move from that position, and that's incremental mode, which is G91. G40 tells the controller to dump any active cutter comp offsets. Cutter comp offsets are used to basically to tell the controller to shift its actual path. G41 shifts it so however many units that you indicate, you shift it that many units to the left of the program path. And it's a tool compensation code is what it is. G42 shifts the units to the right of the program path. And again, these are used to compensate for tooling, but they're really nice to have because you can also use these if you have a tool path and something changes along the way, or you make changes to your parts and you decide, you know what, this needs to be a millimeter larger. Well, you can use this cutter comp offset G41, and you can actually make your controller shift everything to the outside of 0.5 millimeter, and then by the time you go around the entire perimeter, your piece that you carved will be 1 millimeter larger. G49 tells the controller to dump any tool length offsets. Ignore G64. We can't use this in the Onefinity. As far as I know, Onefinity doesn't support it. So now that we loaded the safety block, we go down. And here's another thing that we need to point out. We're going to talk about offsets and the use of offsets, but I want you to notice you don't see your offset loads are G54 G55, G56, 57, 58, or 59. And then G59, you also have 4 extras. You have dot 1, dot 2, dot 3, and dot 4. So for example, G59 dot 4. We won't be using that many, but because we're going to do something a little bit different that I think that you'll really like. But anyway, the only reason I mention that now is because when you start your machine up, usually you home your machine and then you reference your machine, you set off an offset, but you do it, you allow the machine to do it. And the machine does this when you use your touch probe. I don't use a touch probe. I touch off on my piece. But if you use a touch probe, it automatically sets G54 for you. So as we're running, you've already set your offset by the time it reaches this position here. If not, it's going to be based on your home position. So you would basically get an error because 0 on your router is going to be all the way to the top unless you have an offset set. In other words, when you home your machine, 0 is all the way up. So what we're doing when we get to this G-code here is we're telling the controller, drive the Z-axis 8 millimeters or to the absolute position that is 8 millimeters above 0, which is the workpiece, because that's what we zeroed off of, is the workpiece. So this says park the Z-axis 8 millimeters above the blank or the workpiece. And then this next line is rapid traverse X0, Y0, which puts X and Y in the 0 position relative to your offset or home. And then we come here and we have a machine code, and this machine code is M3, which is start, which is spindle start 800 RPM speed. Okay, that's what that is. And then we have another M0, and here's where it's waiting for you to push the start button again. And then we go down and we have a rapid traverse here that places the X axis and Y axis at this position where it lowers the Z. And you can probably guess right now that since we lowered the Z down 3 millimeters, which is 5 millimeters above the workpiece, we are now preparing to do our ramp. Okay. I accidentally call it a plunge sometimes, but it's not a plunge, it's a ramp. We're ramping into the part in this case. So now we get to one of the actual work position or movement commands, and it's G1. And G1 is linear interpolation, and what it does is when you give it a position, it moves whatever axis or axes to that position at whatever programmed feed rate the controller received last. So when we have this G1Z00 F feet, which is feed rate 2400, and keep in mind we're in metric units, so this means travel at 2400 millimeters per minute. Okay, and this is important for what we're going to do. Okay, I mean, it's important anyway, but it's important for what we're going to do because we're going to use this so that we can put markers in here so that we can start separating this code. And I know this might seem time consuming, but I promise you that once you do this a couple of times, I can do this entire thing, that what we're going to do on this video, that's probably going to take about, I don't know, 45 minutes to an hour. I can do this entire program in just a few minutes, and you will be able to also after you do this a few times. So anyway, now that we know here, you push the start button when the spindle is up to speed, and now we rapid traverse to this position. Now we sent G1 which is that linear interpolation. Z is now on the workpiece, and that feed rate is now 2400 millimeters per minute. Now, that's the ramp feed rate. Okay, so then what we should know by this is that when we get to this position here, this particular position, we know that now this is ramp. Wait, begin ramp. Okay, so now we know this is where we're beginning our ramp. How we know this is because we're moving the Z-axis. And when you watch a pocket carve on your CNC machine, or profile, but when you're watching a pocket carve on your CNC machine, you're either going to plunge the Z down or you're going to ramp the Z down, and you're no longer going to move the Z until you carve all of that wood out all the way, which is inside of the pocket vector that you programmed in VCarve. So when we begin to see these motions, these G1s, G2s, G3s, and I'll explain those in a minute. When you see those with the Z motion, you know you are slowly plunging or ramping into your material. So when we get to here, we have this last G1 linear interpolation move with the Z axis moving to absolute 3.167. So it literally just moved to 3.167 millimeters below the top of the workpiece, which means we have successfully plunged, or ramped, sorry, down to where we are going to be carving this first main pocket. So now that we know that what we're doing here, and this is the beginning of the ramp, we're going to back up one moment. I'm going to come up here to where we go to this position. Okay. And we went to this position, and this is going to be, because it's not at 0, 0 anymore, right? So this is going to be main pocket start position is what this is, right? Okay, so now we continue on down our G-code, and we know this is the beginning of the ramp, and we see these Z motions at this 2400 millimeters per minute, and we see these Z motions, and then now all of a sudden we get down here and we see a new feed rate, and we see no Z motion. That means that we are all the way down, and now we are beginning the carve right here. Okay, we actually started carving at the Z motion, I mean at the ramp, I know, but so we're going to say end ramp. Okay, now that we've identified these, I think that we need to also remember that we saw several passes in our program, and we need to identify that this main pocket start position right here, where we lower down the Z and then we lower the Z to 0, we need to put in here somewhere that we are looking at the main pocket carve, right? And then we also need to know that once we go to this Z0 and we begin this ramp right here, we're going to call this main pass 1. Okay. So we've identified the start of the main pass for this first carve, which is that main pocket of the pickup, and we've also identified the ramp. And now we're going to continue down our G code, and I want you to notice that we know that the way the CNC carves is it ramps down to the depth that we're going to carve and carves everything out, and then it takes that entire pass, that path, and it repeats it into another pass, right? The only thing that's going to change is the Z position is going to change, because as it carves, it gets lower and lower and lower because we're subtracting material. So since we know this, we know that we're going to be doing this ramp in every one of these passes. So a quick way to find our way around here is we can click on this and highlight this feed rate of 2400, which is our ramp feed rate, and we know our main pass is our main pass 1 is right above this, right? So now we can turn around and go search and say find, and then say find next. And hey, look, do you see where we are? Now we dropped the Z another negative 3.167 millimeters, right? So we lowered the Z again. And let's back up a minute. And what we want to do is above this, we want to look and see where do we get to the start position again, because it's going to be right above it. And see, this is where we're going to the start position again. So now what we want to do is we want to make sure that we identify that this is the start for the second pass. And I'll show you another way that we can assure ourselves this is the case. Say this 18.239 y minus 1.585. Look at this position. And you will see that it's the same position. And this is going to be the case throughout all of our G-code. So this is where we're going to start. In every case, we're going to be at that position, because again, all we're doing is all this software is doing when it generates this toolpath and this pocket toolpath is it's literally ramping what you told it to ramp, and it's carving away material, and then it's starting over again at that depth, and it's decrementing down the same amount. So it's removing the same amount of material every time. So now we know this is pass 2. This is the start for pass 2. And we don't have to label all of this because we're going to strip this out in a moment. But this is main pass 2, right? And now what we're going to do is we'll highlight this and I'll copy it with Control C. And then I'm going to go over here and I'm going to hit find next. And since I was above this fade rate 2400, it went to this one, and now it's going to go to the next one. There's a reason why I'm doing it this way. I need it to step down. I need Notepad++ to step down each time it finds this, because I need to go above it in order and make sure that I keep these passes in order. And I'm going to hit find next. And this is pass 3, so the next one will be pass 4. And I hope this is helping you guys. And I hope that I'm not going to, I'm trying to go slow, but I also don't want to devour everybody's night or day or whatever it is for you. So pass 5, 3, 4, 5. So I don't remember if we had 6 or 7. I think it was 7, but we're going to do this until we identify all of these passes. And let's see. Okay, so actually, this is why I made the comment that I made about being really careful um, to identify your passes. So we go up and we look at pass 6, and in pass 6 we go to the position 18.239x and y minus 1.585, and then if you look, um, we look at the Z and we start dropping the Z down until we reach 19 millimeters, and this pocket stops at 19 millimeters, right? And anyway, so we go through and we look after this main pass 6, and we look at these positions and see, as we get down here and we carve and um, we get to the end of this, and now all of a sudden we G0, which is rapid traverse, to 5 millimeters again. And that, keep in mind what this is doing. We basically just sent the head, or the mill, the spindle, all the way, the tool is all the way up above the workpiece, 5 millimeters. Okay, so that means this is not the main pass anymore, or main pocket pass. And this, we've got two screw pockets, and one of them is going to be on the negative side and one of them is going to be on the positive side, because 0 is in the center of the pocket. So we know this is going to be the left screw pass 1, right? This is where it locates to. This is the start position, and this is where we drop the Z down to 19 millimeters below the surface. Now here's the reason why we did this. If you watched my video where I explained you having a strategy for how you do these combinations of pockets or different tool paths, your goal is supposed to be to prevent, remove, eliminate all wasted motion that you can possibly identify. So that's why we did the main pocket, and then we have these two small pockets that are really the same as what we use to draw on the outside of this pickup pocket. And we did that because we want to start at the bottom of the pocket we carved when we start carving, because we don't want wasted motion. So here is where we start our ramp for the left screw pocket. So here, let's add a comment in here so that we know that, once we get to this point, we know that this is begin ramp. In fact, if you want, we can call this LS ramp for left screw. And then, just like we did on the main pocket, we're going to continue down here until we see the Z stop moving and we see our new feed rate. And our new feed rate, again, this is where we're actually doing the work. So we come here, the line above it, the last one with the Z, and right below it we say end LS ramp. And we only have to do this on the first pocket, or the first pass. And if you haven't figured it out yet, I'll just tell you right now, the reason we're only doing this on the first pass, I'm only doing this with you guys to show it to you, because truthfully, by now I would have identified just the first pass and deleted everything else, right? Save a copy of your G-code into a new name, right? Like, call it whatever you called it when you generated it. Call it stripped or edited or working or whatever until you're finished, so that you still have your initial G-code that works. But we're going to strip all of this other stuff out, because we don't want 600 or 700 or 1,000 lines of code to do this little carve. We want whatever's required for the motion to carve a pass, and then what we're going to do is we're going to shift our offset and we're going to repeat it, and you'll like this. It's pretty handy. But anyway, So we end the ramp here, and now we go on down. We can do this with the find all, but we don't need to because these small pockets, they're not, there's not a lot of code to them. But if you're doing a different program, again, take that speed where you know your feed rate, is, here, let's do this. Let me highlight this too. Where you know your feed rate has dropped. And the first time, since we're doing find next, is right below where we labeled it. And now we're going to go down here, and if you look, we're right back in that start position right here, right? And we've decremented the Z, but here's the start position, right? We're right back in that start position. So now what we want to do is we want to go here, and this is the beginning of the second pass. So we're going to say, what was it, left screw pass 1. So let's highlight that and copy it, and let's just write over that, and let's call that left screw pass 2. Okay. And if I get lost in these because I don't sleep much, so I like to just highlight the one that I just did, and then find next. There's that position right above it again, where we're going back to the start position. So this is going to be pass 3, and again, just highlight that and copy it if you don't want to keep up with it. And then this is pass 4, and I think all we have is, I think we only have 4 passes on these, but where we have this X 30 minus 37, we're going to do this again. We're going to do find next again, and then we're going to look at the position it goes to. Do you see this? You notice this is positive. So now that means that now we are on the right side instead of the left side, and we know now that this is the right screw pass 1. And I hope that I'm doing a good job of explaining what we're doing here, but we went up to the Z. I'll show you here. Let's step back up. When we did this last pass for the left screw pocket, if you notice at the end of it, we get down here, and we raise the Z axis 5 millimeters. So we go up. This is not the bottom of the pocket, because we're still using that initial offset. So this is all absolute right now relative to 0, 0, 0 when you set your offset. So right now your end mill is 5 millimeters above the actual workpiece, and then what we're doing is we're rapid traversing it to that positive X position, and then we're still at Z5. And then now all of a sudden we drop it down, we linear move Z to minus 19 millimeters, right? So that means this is the screw pass, okay? And now this is, and I think we labeled them begin ramp. We'll call it RS ramp. I think we called that LS ramp. And then how I know what we're doing is we start 19 millimeters deep, right? And we changed our feed rate to the ramp feed rate. And now we're moving the Z axis and we're just slowly decrementing the Z axis down. And then now we're at the bottom of this pass, because we're not moving the Z anymore. That's how we know. So this is going to be end RS ramp, right? So now we're going to highlight this right screw pass 1 and copy it, okay? Because, well, actually, yeah, let's Okay, the first time we hit Find Next, we're going to go to this feed rate right below where we labeled. We hit Find Next again, and just like we did before, we look up, and the line before it is the motion to go to our cut path start before we decrement the Z again. So we go here, enter, paste, and this is right screw pass 2. You don't have to do this way, but find next again. And I know if it seems like I'm rushing through this, I'm sorry. And if anybody wants if anybody wants me to go back and make a slower, more in-depth video later, I'll be glad to. I really don't mind teaching this stuff. I wish someone would have taken the time to teach it to me. But anyway, so we knew we had 4 passes. So now we've got the right screw pass 4, and we continue down. And we get to the end of this, and we know we're at the end of it when we see this rapid traverse where we're raising the Z to 5 millimeters above the workpiece again. And then we have this M5, and M5 is spindle off. Okay. And then we have G0, Z8, which parks the mill at our offset position plus 8 millimeters. So we are now 8 millimeters above the workpiece, which is where we were when we hit cycle start. And G0, X0, Y0 just make sure that the end mill goes to the 0 position that we set our offset for. And M2 is program end. Okay. So that wasn't so bad, was it? That wasn't so bad. Now, we have everything labeled that we need, but there are some things that we have to do to this.